So we're solving trig equations. A trig equation is an equation involving a trig function. That should not be a shock, right? So that when I say the cosine of x is equal to 1/2, right? Then I'm looking for all the x values for which this is true. And in particular, for the one that I think that we were just looking at, the question was, is pi over 6 a solution to this? Solve this. Right? That is to say that if you plug in pi over 6, do you get a true statement? The question is that true? Cosine of pi over 6 is the cosine of 30 degrees. The cosine of pi over 6, according to the circle, is square root of 3 over 2. The answer is no. No. Cosine x equals sine 2x. Is x equal to pi over 2 a solution to that? So is the cosine of pi over 2 equal to the sine of 2 times pi over 2? Is the cosine of pi over 2 equal to the same thing as the sine of pi? Is 0 equal to 0? Plug in pi over 2 for x and see if you get a true statement. That is a solution. Solve this one. Find the x such that the sine of x is the square root of 3 over 2. What x gives you all these answers need to be in radians? Find the x such that sine of x is the square root of 3 over 2. What x is that? Pi over 3 works. The only difficulty in here is that pi over 3, 2 pi over 3. How many answers do we have? Oh, they want every answer on the real line. They want all of those. So everywhere this intersection happens, right? They want those two, which I think you said, right? So, and I think Desmos is nice in labeling them. Pi over 3, 2 pi over 3. You can see those things right on the circle. With this one, 7 pi over 3, 8 pi over 3. Right? I'm being biased, right? There are 2 over here, 2 more. Right, so we need to find a way of writing all the answers. Okay, so we just have to write all the answers. Okay. And so here's a way to write all the answers, right? So you would find the 2 that work, right? So it would be pi over 3, right? Pi over 3 and 2 pi over 3, and then you would recognize that the period of the sine is 2 pi. It repeats every 2 pi units, right? And so then the way that you would say all the answers, you would say pi over 3 plus every multiple of 2 pi, comma 2 pi over 3 plus every multiple of 2 pi. That's how you have to put the answer in. So this is what they mean about entering in using n as an expression. So if you want to find an answer, it has to be pi over 3 or pi over 3 plus 2 pi, pi over 3 minus 2 pi, pi over 3 plus 18 pi. Any even multiple of pi added to pi over 3 is an answer. So this is a way of getting all the answers. Pi over 3 plus 2n pi, comma, 2 pi over 3 plus 2n pi. And so the answer on the steps to this are find the answers on the unit circle. And then add 2n pi to both. That's what happens when you have to find every single solution. Right? That's what happens when you have to find every single solution. Find the two that work on the first rotation of the circle and just keep rolling around the circle forever, right? That's all we're saying. It's a mathematical way of saying that. Try that one. Where's the tangent of x equal to 1? This one's slightly different. So tangent of x is equal to 1. In other words, where are the x and y coordinates the same? Pi over 4 and 5 pi over 4. Now what's nice about this one is that we could write, and I don't know what my math app's going to do, we could write pi over 4 plus 2n pi, comma, 5 pi over 4 plus 2n pi, right? But there's one way to write this. We could write this just by writing one statement, pi over 4 plus n pi. Because 5 pi over 4 is pi away from it. So you're just moving pi away, right? This one statement takes care of both statements. Let's see if we can see that from the cheat sheet. When we look at, scroll down, where's the circle? Yeah. So just a tad. So when I see pi over 4, right here it is. When I add pi to it, it takes me here. And I add another pi to it, it takes me there. So pi over 4 just plus pi's gets you to either pi over 4 or 5 pi over 4, both of which have the same x and y coordinate. The tangent of all of these angles is 1, right? So pi over 4 works. Just that one statement by itself works. You can try either one. Hopefully the programmer is not going to mark this one wrong. All of those, where's the cosine equal to -1/2? Go to the circle. Looks like we got x equals, I don't think they're probably too apart from each other. Cheat sheet, -1/2. 11 pi over 6. Wait, the cosine, right?
Yes.
So the x coordinate.
2 pi over 3.
2 pi over 3. Oh, so we got to be over here. Yeah. 2 pi over 3 and 4 pi over 3. Right. So yeah, you would just do both of those and add 2 pi to both. So 2 pi over 3 plus 2n pi. We're still using n, right? Yeah. And then 4 pi over 3. 2n pi gets you all the answers to that, all the solutions. At some point, we're going to start restricting the domain of this. Down here, they want all the solutions to this. So now we got an equation. I'll take this one. Actually, we move this to the side. We have 4 sine theta plus 1 equals 2 sine theta. We want to get theta by itself. So in the moment, we want to just get sine by itself. So we just subtract 2 sine theta on both sides. Subtract 2 sine theta. Trying to get theta by itself. So then we got 2 sine theta. Let's be clear. I got 4 of these minus 2 of these. This leaves 2 plus 1 is equal to 0. Trying to get theta by itself, 2 sine theta equals -1. The sine of theta. Thank you, brothers and sisters. I appreciate that. Sine theta equals -1/2. And then we go back to the circle. The reference angle for the sine of theta being 1/2 is pi over 3. I'm sorry, pi over 6. So for -1/2, if we're talking about theta being
3 and 4 quadrants.
the 3rd and 4th quadrant, right? 3rd and 4th quadrant. So over 6, looks like 7 pi over 6. And then the other one is 11 pi over 6. No. And plus 2n pi, comma, plus 2n pi, all from the circle. So yeah, just solving these just like you're solving for x, right? So subtract 2x on both sides, divide by 2. It just happens to be sine in this case. Got 19 of these. They're pretty straightforward. Want every solution here, but only in this interval. Only in this interval. So we'll go through this very carefully, putting out the steps. So in order to do this, so then first is that you use the circle to find a statement. For all solutions. So you do that first. So from the circle, it looks like 2 theta equals, what angle gives you square root of 3 over 2? It's pi over 3, right? Plus 2 n pi. Thank you. So 2 theta is equal to pi over 3 plus 2 n pi. Taking questions on that. Straight from the circle. I'm looking for theta though, right? So then I need theta. I divide by 2. So then solve for theta. Right, so then I'm going to divide everything by 2. So theta equals pi over 6 plus n pi. And then find the n's, the right values of n. That keeps theta between 0 and 2 pi. Right? The answer has to be between 0 and 2 pi. Right? Okay, so that when n is 0, theta is pi over 6 plus 0 times pi, which is just pi over 6, and that's good. When n is 1, you get theta is pi over 6 plus pi, which is 7 pi over 6, and that's between 0 and 2 pi. When n is 2, theta is pi over 6 plus 2 pi, and that is 13 pi over 6, and that is no good, right? And so these two are the answers. Those are the only angles between 0 and 2 pi that solve that equation. So the steps are, look at the circle, find all the answers, solve for theta, and only pick the answers by letting n run that fit in the interval that you care about. We'll see how bad these equations can become. Did I copy this one? It looks like I did. So 6, 5, we were here. How bad does this get? Tangent of x over 3 is equal to 1. Same thing. Try and do that one. Go through the steps again. 0 to 2 pi. At this point, we know that tangent, got a lot of different answers for this one, right? Let's go up there. So now we know, so first step, 1, we need to use the circle. And we know that, we said this earlier, that x over 3 needs to be equal to pi over 4 plus n times pi. We multiply both sides by 3, right? So solve for x. So x is equal to 3 pi over 4 plus 3n pi, and I have some serious concerns. Run in and pick the values that fit. When n is 0, then you get x is equal to 3 pi over 4 plus 0, which is 3 pi over 4. And that looks like that's going to be the only one. When n is 1, you get x is equal to 3 pi over 4 plus way too much. Right? That's 15 pi over 4. Which is bigger than 2 pi. One and only one answer. Cruising through. All right, so here we're gonna have some quadratics. We're not intimidated by this. And so here, the remark for this one is that this is just a quadratic. We're going to solve by factoring. So just think of this as 2u squared plus u minus 1 is equal to 0. And I often do this, right? So I'll let u equal the sine of theta so that we can see that this is a quadratic. And when we see it's a quadratic, we can go ahead and solve for u. But if we can solve for u, then we can get theta by itself as well. 2u squared plus u minus 1 is equal to 0. Factor. This is prime, so that has to be 2u and u. And the question is, where should we put negative 1 and 1 so we get a plus 1 in the middle?
Negative 1 plus 1.
Negative 1 plus 1, right? So factoring. And so here, we've got that 2u minus 1 is equal to 0, or u plus 1 is equal to 0. We got 2u equals 1, u equals 1/2, or u is equal to negative 1. You just have to remember that I introduced the letter u. I was never interested in the letter u, right? U is sine. I want the sine of theta to be 1/2, or the sine of theta is negative 1. This happens in 3 places. The y-coordinate is equal to 1/2 in pi over 6. Where's the other place? 5 pi over 6. And the sine of theta is equal to negative 1 at 3 pi over 2. So to separate those 3 things with a comma. So it goes into my math lab. That's pi over 6, 5 pi over 6, and 3 pi over 2. Those are the 3 places. So when you see a quadratic in sine, cosine, in the other pre-calc class that I covered for, they did this for the exponential function. But whenever you see any quadratic like this, something squared plus that very thing minus 1, you can write it as a quadratic. I think they played this game a couple of times in this homework, where the next one is this one, right? The only one the answer is here. And so 4 cosine squared minus 1 is equal to 0. Let's add a page here. So for you don't have to, but just in case you would like to, then use cosine x. 4u squared minus 1 is equal to 0. 4u squared is equal to 1. U squared is equal to 1 over 4. I'm sorry. So this means that u is equal to what? The square root of 1 over 4, plus or minus. So u is equal to 1/2 or negative 1/2. I introduced the letter u, so either cosine x is 1/2 or cosine x is negative 1/2, and we just need all those angles. That's when x is, the 1/2s are over 3's, right? Pi over 3, 2 pi over 3, 5 pi over 3, 7 pi over 3. 7 pi over 3 is 4 pi over 3, that's right. So 5 over 3 is way too big. Okay. So 1, 2, 4, and 5. About that. So making a substitution. Okay. Take care of that one. How funky do these get? Oh, same thing here. Cotangent, they have already factored everything for you. Cotangent theta needs to be 1, or the sine of theta needs to be 1. It's all circle. Here, this is the same thing as tangent theta being 1. Right? So again, we're talking about pi over 4, 3 pi over 4. Sine is 1 only at pi over 2.
5 pi.
Say it again?
I think it's 5 pi over 4, not 3 pi.
Yes, it is 5 pi over 4. Circle. That's right. Third quadrant. Equal to 0. Here, same question. They both have cosine in common. It becomes a factoring problem. Cosine times 1 plus 2 sine theta, or x in this case, is equal to 0. It means that the cosine of x is 0, or it means that 1 plus 2 sine x is equal to 0, in which case sine of x is equal to minus 1/2. We go back to the circle. The only thing to be, there's really nothing to be concerned about here. Cosine x is 0 when x is pi over 2, 3 pi over 2. Sine x is negative 1/2 when x is, so 1/2, we need the over 6's, right? And so then we need to be negative, so it has to be in the third and fourth quadrants. Looks like a 7, and the other one is 11. So even today, I still have to think it through, right? Instead of having it just completely memorized. So this factor, 13. 13 is one where you can manipulate this. We know that cosine squared is 1 minus sine squared, right? So we knew that it would be hard to solve this unless they were all saying the same things, right? So this would be equal to 2, and you want to write 1 minus sine squared plus sine of x minus 1 is equal to 0, right? And so doing some simplifying, distribute the 2, 2 minus 2 sine squared x plus sine x minus 1 is equal to 0, minus 2 sine squared x plus sine x plus 1 is equal to 0, and then multiply everything by minus 1. 2 sine squared x minus sine x minus 1 is equal to 0, and then it becomes one of the problems we just did earlier, right? 2u squared minus u minus 1 is equal to 0. 2u minus, right, plus 1. U minus 1 is equal to 0. So u is equal to minus 1/2, or u is equal to 1, And then again, U was sine. Sine x is minus 1/2, or the sine of x is equal to 1. And again, it's just a circle. (14) Slightly tricky. So just be careful. This is also a calc issue sometimes. All right, so sine of 2x, you're gonna write that as 2 sine x cosine x is equal to negative square root of 3 cosine x. Right. Some people here like to just go ahead and divide out the cosine. Don't ever do that. Don't ever divide out the cosine. Okay. Why not? Because sometimes the cosine could be 0. So you don't want to divide out something that could be 0. Right. So then what you want to do is bring everything on both sides and factor. So you have 2 sine x cosine x plus the square root of 3 cosine x is equal to 0. And then they both have cosine x in common. 2 sine x plus the square root of 3 equals 0. So notice you factored out cosine from each one. So you move this out, you're left with 2 sine x. You remove this, you're left with the square root of 3. And so either the cosine of x is 0, circle, or 2 sine x plus the square root of 3 is equal to 0. And looks like, again, solving for sine x is negative square root of 3 over 2. And again, we're back on the circle again. All right, so I'll leave that to you. We're almost there. This one's going to be a pain to try and solve by hand. We just need to be familiar with the circle. And this has to do with the number 1, that there's only one place where the difference in these two things is equal to negative 1. Right? Where is the sine and cosine the most away from each other? What angle is that? Looking at the circle. Say it again. It's at pi over 2. This is almost just by inspection. The other way to think about it is that in order for the difference to be 1 or negative 1, one of them has to be 0 and the other one has to be 1 or negative 1. Whenever one of them is 0, the other one has to be plus or minus 1. And we know that to be true, right? Because sine squared plus cosine squared is 1. So if one of them is 0, the other one, being squared, has to be 1. And therefore, if one of them is 0, the other one has to be plus or minus 1. The only answer is pi over 2. A 3 pi over 2, you get positive 1.
It says pi is an answer.
I am loving pi, actually, as an answer, right? So that, so that you should just look at all the places where you have 0 and 1 for the choices, right? So, so you should put in 0, pi over 2. You should put in all the points on the axes, right? 3 pi over 2, pi, and 2 pi. Is 2 pi allowed?
Same as you.
It just wants on this interval. So you see the parentheses here? They don't want you to include 2 pi. 2 pi has been left out, yeah. Yeah, so just check the axes. So that's the...
That's how we know pi also?
So yes, because pi is also on the axis. So we're checking this one, this one, this one, and this one. And that one's pi. Yeah. Those are the places where you have the largest difference between the two. Use a calculator to solve that thing. Funky. Let's do this one. What are we going to need to do? Go to the calculator and do the what? Inverse sine of negative 0.3193. We actually do need a calculator for that. Let's do the inverse sine. This needs to be in radians.
-0.
Say it again?
Put the calculator.
Inverse, yeah, sine inverse. So yeah, sine inverse of negative 0.3193. Tell me what that is. Okay, so that is approximately negative what?
0.34.
They want 4 decimal places for our answer, so let's give a bunch of decimal places for this. Negative
0.324.
0.3245.
Hold on. 0.3250.
50.
Yeah, 50.
250.
Yeah.
Okay,
Because it was rounded.
so that's what you want to do? To 4 decimal places.
Yeah.
To 4 decimal places. Okay, so could you give me 6 decimal places for this, please?
Negative 0.32499907.
Okay, I feel good. I feel better now. Okay, I just wanted to make sure. Okay, all right, great. So now, what quadrant? By the way, this answer is not in this interval, right? What quadrant is this answer in?
2, 3.
One of them.
It's in one of the quadrants. That's right. Where does inverse sine live? Where does inverse sine live? In the first quadrant. And what's the other place where the inverse sine? In the fourth quadrant. Right. This answer is in the fourth quadrant. And so how do I bring it? How do I bring the correct answer in? What do I have to do to this? I do need to go into direct. I need to do what to that number? I need to add something to it. It's in the fourth quadrant, right? It's a negative number in the fourth quadrant. So if I did this, right? If that's negative 30 degrees, how would I make it something that's in here? What would I do to it? You would add what?
2.
Yes, you would add 360 degrees. So then you just need to take that number and add 2 pi, and that's the number they want.
That's tricky.
Yeah, that's why I'm talking about it. Yeah, that's tricky. And then round that to 4 decimal places. Yeah. So this has to do with the fact that this angle ends up in the fourth quadrant, and they want an angle that's on the original circle. So you add 2 pi to it, and it takes it into the correct place. What'd you say? Yeah. Oh, great. So same thing, u squared. I'm afraid though, minus u minus 1. I may take this one out, only because, yeah, they're going to want the quadratic equation, right? Yeah, I mean, this is a pain.
Extra credit.
Maybe extra credit, right? So then, first of all, we can't factor this, right? So then we've got u squared minus u minus 1 equals 0, a equals 1, b equals negative 1, c equals negative 1 as well, right? U is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Maybe these things are complex and there's no solution, right? So this is going to be negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 1 all over 2, 1 plus or minus the square root of,
5.
that looks like 5, all over 2. And I'm worried here because this looks like the cosine of x is equal to 1 plus or minus the square root of 5 over 2. And I'm worried because one of these looks like it's bigger than 1, which would be impossible. I'm not liking this one at all, right? Isn't that bigger than 1? The square root of 5 is bigger than 1, right? Isn't the square root of 5 is bigger than the square root of 1, isn't it? 1 plus the square root of 5 is bigger than,
2.2.
yeah, this is bigger than 1. So this is not a solution. Right. Why not? Because the cosine isn't bigger than 1, is it? The cosine is always between negative 1 and 1 because it's the x coordinate on the unit circle. So this means that the cosine of x has to be 1 minus the square root of 5 over 2. And then you just do the inverse cosine of that. You just do the inverse cosine of that, right? And so then x is the inverse cosine of 1 minus the square root of 5 over 2, right? What is that? That's going to give you some value, that's negative. That's going to give you some value in the second quadrant. And then what do you need to add to that? You need to do this number to pull it back to the first quadrant. No. Something's in the second quadrant. Well, I'm sorry. So this would be good, right? Is 0 to 2 pi? Yeah, no, this would be good. It'll give you the right place. It's going to give you something between 0 and pi. That's good. So yeah, you just take that answer, whatever that is. All right, so solve quadratic formula, do inverse cosine. Super ugly. Last two. Whenever you see sine 2x and sine x living, you got to change the sine 2x to something else. You just have to change it to 2 sine theta cosine theta and utilize the circle, right? So the whole point of these exercises is just to drill in your head these formulas so that when you see them in calculus, they both have sine in common. Just know that they exist. So then the sine of x is 0, or 2 cosine x plus the square root of 3 is 0. Circle time cosine x is minus the square root of 3 over 2. And then use the circle. So it's here where we get a super practice with the circle, right? You do 19 of these problems where you have to go back to the circle over and over and over again. Then you're going to have these things memorized, right? So use the identity. This is an identity. It's the double angle identity. Factor, set equal to 0 and solve. For the game, more factoring. I think this does factor. I don't think you'll need the quadratic formula for this one. Bring everything to one side, make a quadratic equation, factor, and we will solve. It looks like we've got we can divide everything by 2 first. There's no reason to have any extra factors that we don't need. Sine squared x plus 3 sine x plus 2 equals 0. U squared plus 3u plus 2 equals 0. Factors of 2 to add up to 3. 2 and 1. Yep. U is equal to negative 2. And U is equal to 1. U in this case is sine. Say it again?
Negative 1.
Thank you, I appreciate that. Sine of x is equal to negative 2. Sine of x is equal to negative 1. The sine is the y coordinate on the unit circle, so that could never be negative 2. The only angle with the y coordinate is negative 1. It's 3 pi over 2. Okay. That takes care of this entire chapter. Okay, so next week I will show you what the practice test looks like, right? This homework is due, so 6.3 is due next Thursday at midnight, and then this homework is due that Sunday at midnight. So, and then I'll show you the practice test, give a due date for that, and then we'll start chapter 7, where we start to now ask about if I have any triangle, right, and I have two sides and an angle, can I find every side of the angle, no matter what. It's called the law of sines. We'll prove it, and then we'll do the law of cosines right after that. That's in there. There's some homework due tomorrow at midnight. I'm going over to 1710 if you want to work on that, finish it up.